Hi, in this video we'll talk about variance schedule. Let's say that we have x0, which is our clear image. We will add noise to this image. Let's call it noise 1. Here, the level of this noise will be very small. And as we said previously, we will use the standard deviation of the Gaussian noise to control the level of the noise that we will add. In other words, the variance of this noise, it is very small. Let's say that the variance of this noise, it is equal to 0.0001. So now we have this distribution that we will use to pick the value of x1 variable. Now we are at time step 1. We will add noise 2 to our x1 image. And here the level of noise 2, it is greater than noise 1. Or in other words, the variance of noise 2, it is greater than the variance of noise 1. And the value of the variance of noise 2 will be equal to the value of the variance of noise 1 plus the step size. We will talk about how to compute the step size or variance difference later. So now we have this Gaussian distribution that we will use to get the value of x2 variable. We will get x2 at time step 2, and we will add noise 3 to this image. And here we will again increase the variance of this noise, or we will increase the level of the noise that we will add to x2. Now the variance of noise 3, it is equal to the variance of noise 2 plus the variance difference. So here the variance of noise 3, it is greater than the noise 2, and the variance of noise 2, it is greater than noise 1. Let's say firstly, the variance of noise 1, it is very small value, which is, let's say, 0.0001. And let's say that the maximum variance that we want is 0.02, and the minimum variance is 0.0001. So we will compute the difference between these two things, and we will divide the results by the number of steps, which is 3. The result will be 0.0099. This is the amount that we will add to the variance of the previous noise to get the variance of the noise that we will add at the current time step. We will call this amount the step size. Okay, so firstly, the standard deviation is equal to the minimum standard deviation. So here the variance of noise 1 will be equal to the minimum variance, which is equal to 0.0001. And now we are at time step 1. We will add the step size to the previous variance. So we will get 0.0001 plus 0.0099. And now we are at time step 2. So again, we will increase the level of the noise. So here the variance of noise 3, it is equal to 0.0001 plus 0.0099 plus 0.0099, which is equal to the variance maximum value. Let's say that we want to make the maximum variance equal to 1. At this case, x3 will be just standard Gaussian distribution or normal distribution, where the mean equal to 0 and the standard deviation equal to 1. At this case, we will lose all the information about x2 value. Our x3 variable here, it is just a pure noise without any information. We call this variance schedule linear variance schedule, because here we are increasing the variance of the previous step by fixed amount in the current step, which is the step size. So here we are increasing the value of the variance linearly. We said previously that we will use alpha rather than the variance. So here, let's say that we want to compute alpha bar 1. Alpha bar at time step 1. It is equal to alpha 1, which is equal to 1 minus the variance at time step 1. Now, let's say that we want to compute alpha bar 2. Alpha bar at time step 2. It is equal to alpha 1 times alpha 2, which is equal to 1 minus the variance at time step 1 times 1 minus the variance at time step 2. And let's say that we want to compute alpha bar at time step 3, which is equal to alpha 1 times alpha 2 times alpha 3, which is equal to 1 minus the variance at time step 1 times 1 minus the variance at time step 2 times 1 minus the variance at time step 3. So now we learned how to compute the value of the variance at each time step and how to compute the value of alpha bar at each time step. Finally, we can use this formula to get the value of xt variable at any specific time step. This is the Gaussian distribution that we will use to get the value of xt. We can compute the value of alpha bar, and we have the value of x0. It is our clear image, and we can pick the value of epsilon 0 from the standard Gaussian distribution. So we can get the value of xt variable